So I think we can move on. We have last session, we have a panel on actually the main topic that we had today, and this about the role of large language models in the area of community system research. So the panelists are Antonio Chella, Rachid Alami, and Ken Forbus. So please, I think you can come here and we can have a sort of panel and then a joint discussion about this issue. Ok, Agnese, possono essere registrati? No, no. Okay, so well, you know, we had this entire session about large language models. Nowadays in AI, we have, let's say, plenty of papers working on large language models, but not only in AI, also in robotics. I mean, you have roboticists here. So my, let's say, first, question is that something that I would like to discuss is, okay, so how do you see and what are I think the pros and cons of using this kind of system, this kind of architectures in order to, I don't know, enhance the kind of system that we are building in this community. So how do you, let's say, figure out what can we do and what we cannot do with this kind of models? So it's up to you. Ken, do you want to start? Yeah.
Green, got it. Green means go. Okay, so look, I'm the people who think that large language models are the coming of AGI. I find sort of sad, and it shows the power of the Eliza effect and clever Hans in fooling people, and many people have fooled themselves. That doesn't mean that they're not useful. So in our own group, in an experiment on knowledge capture, learning by reading, we used BERT fine-tuned with FrameNet semantics to help disambiguate. The main heavy lift was being done by our analogy question answering training method, which is data efficient, et cetera. And BERT was also used to kind of do a statistical fact check, okay? And so analogical QA training got a particular percentage accuracy. And by adding BERT in those two roles, we got another 10% accuracy, right? So it was a big improvement. So that was cool. But the same BERT fine-tuned models were actually negative performers on other data sets we tried. So in other words, even though it's FrameNet frames and general purpose stuff, what someone said earlier today, the statistics of the text you train on are the statistics of the text, and you change those statistics, and fundamentally you have a problem. And with the GPTs, you're supposed to be getting rid of that by having billions, right? Massive more stuff, but then the problem is it just doesn't get very much. Another experience that sort of shows the trade-offs. So I teach a conversational AI class. I do it every 2 years. So, of course, doing it this time was after the whole ChatGPT thing happened. Google, bless their hearts, provided access to Gemini. So 8 teams. One team insisted on using GPT-4. They did terribly. The teams using Gemini did pretty good systems, but none of them was just a straight language model. Okay, I mean, all of them had multiple modules using the language model multiple times, and all the things you see in the literature about the trade-offs in RAG and the trade-offs in fine-tuning and the trade-offs in prompt engineering and the trade-offs in few-shot learning, They experienced all those things. They were able to build reasonable systems. Example, there were 3 cooking assistants, and one of them, when I said, they sort of said, well, what ingredients do you have? And I said, well, I have a lot of cicadas in my yard. And in fact, one of them came up with a pretty good Kung Pao cicada recipe. Okay. And that, well, another one was able to tell me that you had to peel the cicadas first because the exoskeletons are not digestible. Okay. So that was way beyond what anybody expected from the systems. Another one that actually would have a little debug thing where every time it violated a Gricean maxim of communication and conversation, it would tell you what maxim was being violated. And if you know those maxims, you'll know quantity is one that LLMs regularly violate, right? They blather, they tell you too much stuff. And so that one, it was an advising thing. So I said, well, okay, I want a career like Stephen Colbert. And it said, many Northwestern students go into comedy by blah, blah, blah. In fact, Colbert's a Northwestern alum, so it was pretty clever that it made that connection and it figured out what to major in. So all those things, they weren't panaceas, but the students were able to build in a few weeks systems that were much better than they could have built otherwise. Now, these are going language to language. When you're going language to reasoning, I don't know how Bob Ray's system does the last mile problem, right? Getting to actual predicate calculus inside the system. That's hard. So Scikor has been training systems, and they can get about 80% accuracy with GPT-4 producing ground atomic formulas. And if you know their logic, it's omega order logic. It's very complicated. So those ground atomic formulas cover a lot. Okay. So it is possible to do that sort of training. But part of it is that we don't have a universal ontology and symbolic representation system that everybody picks up and uses. And if we did, then actually you could have people training language models to produce that for us. That would be, to me, nirvana. I'll stop there.
Yeah. Okay, so Antonio or Rachid, yeah, Antonio. Okay.
So obviously the first move is asking a large language model, which is the role of a cognitive system in large language models. So I asked Claude 3, not ChatGPT, but Claude 3, which is similar to ChatGPT, what is the role of cognitive systems in large language model? And the answer is essentially it's quite interesting. So Claude 3, the answer is foundation. So cognitive system could provide the theoretical conceptual foundation that underpin the development of large language model and so on. Complementary capabilities. So while large language model excel of natural language understanding, generation, reasoning task, cognitive system may bring complementary capabilities on the table, perception, multimodal reasoning, and so on. It's interesting. This is an interesting notice. The third point that made Claude 3 is explainability and interpretability, because large language models are complex and opaque. Cognitive system can help in making the inner working more explainable and interpretable. Human-AI interaction, ethical and societal implication, cognitive architecture. I'm skimming through the list. Cognitive architecture, because according to Claude 3, cognitive architecture like SOAR, ACTAR, and others provide a framework for the integration of large language model with other cognitive capabilities, and so cognitive benchmark, and so on. So in my opinion, it is an interesting list because it poses some aspects which are important in analyzing large language models in terms of cognitive systems. In my opinion, one of the points, some points are very interesting. Essentially, we have to take into account the fact that cognitive systems is mostly related to the fact that the interest in cognitive systems community is to better understand the human brain, is to better understand how the brain works, how the brain works in some sense. While the people that works on large language model are more from the AI community. So it seems to me that this discussion is related to AI versus cognitive systems. There are some points, of course, there are many points in common, but there are several points of differences. So because people in cognitive systems are mostly interested in how the brain effectively works, while people in AI are not all the people in the AI are interested in how the brain works. They are mostly interested in making better systems, making efficient systems, and so on. And I suspect that many people that works in large language model are not so interested in making a large language model as a kind of copy of the human mind. They are interested in doing something which works very well. So we should take into account this aspect. And the third point that I would like to stress is that if we have to reconsider maybe we have to reconsider some aspect of cognitive systems. So many people, including myself, who discussed about the common model of the mind and the standard model of the mind and so on. It's difficult to frame the operation of the large language model in terms of a common model of the mind, or considering the tools that we have from cognitive systems. Maybe in order to describe, in order to understand how a large language model works, we have to create some kind of new tools. It's just like I'm very simplifying, but consider a different kind of cognition. For example, I was thinking of the cognition that came from the autistic people, for example. It is a different cognition from our cognition. We need to consider different tools in order to understand the cognition from I say autistic children in a very simple sense. So the problem is much complicated than that. But anyway, so we need different tools to understand how the autistic brain, let's say, works. So we need different tools to understand how large language model works. And the last point is the problem of integration. Many people are in the literature are considering, even Alessandro today is considering the possibility to integrate a large language model with other systems. For example, in a robot, we need a perception, we need action, and so on. And maybe also in this case, we need a different tool. We need, together with Antonio, we wrote a paper on the need of a lingua franca for the integration of different aspects in a cognitive system. Maybe we need some kind of lingua franca or some kind of subsystem that allows us to integrate this. But maybe it's not only the problem of integration. It's a problem of theoretical reflection to understand what is cognition. There are different ways of cognitions, and maybe we are in front of a different artificial cognition, which is different from our cognition. And I stop here.
Okay, let's go with Rachid then.
Yes, thank you. Okay, so I think you have largely started the discussion and put it, I would say, in the like I would like to contribute to. I will take my strict point of view voluntarily. I am interested in intelligent robots that which act and interact with humans. So I have some requirements, some kind linked to this, so that this robot has to perform the task, but also has to satisfy a number of properties. Number of safety, etc., and pertinence, relevance, of what it is doing, etc. And now looking at, and I agree also that there was this issue about the interesting difference between cognitive science, I would say, and AI that you will make in one. And I have to say that, for example, today there are a number of things that we were not able to do before and we are now able to do. For example, for robotics, grounding, associating a name to an object. Find a bottle here. This sentence could be solved very easily today with system. So it's not only LLM, it's a VLM, for example, help a lot for that. Really help a lot for that. Of course, finding a bottle doesn't give you what is a good bottle, how to take it, how to reach it, who can reach it, etc. But still, I think there are very important steps that are now available and provided for grounding. And I think grounding is working quite well today for objects, not that well for relations. Grounding relations still have to be refined, and we reason a lot about relations. We need relations. It's key in what we are doing. The object, okay, but what is important for this object is the relation I will have with it, I would say, essentially. And so, and human-robot interaction, again, the relation is key, and the relation takes a number of levels here. Now, what I can see, but so we can have discussions several steps. I think the main issue is that clearly, as an engineers, it's a tool. There are tools available today that could be used and integrated in our system because it will help. It will open things, etc. Of course, they have to be integrated in a way that we guarantee some kind of thing. For a robot that acts, you cannot, even in some situations in human-robot interaction, the robot could be defective, could make errors. It is acceptable. In some situations, it must not. It should not make error. And this could be taken into account when building such systems where when uncertainty is acceptable and error is acceptable, then you could rely on some issues. In other situations, you should not. So I think it opens a large avenue for looking to things. Of course, LLMs and VLMs are improving. In robotics community, there is something also that is missing, particularly in human-robot interactions. There is no corpus of human-robot interaction today. There are corpus of human-human interaction, even though it has to be refined, but no corpus on human-robot interaction. And for me, I insist on the fact that human and robot are not equal. We cannot simply do this. Take an example. I'm taking a very simple example, and I would like to comment this. When you look to ChatGPT 4.0 today, for me, when I hear it, I feel that the corpus is essentially in this talk show of this TV. They are very good. Where you have the journalist that plays with the with the invited guy. Okay, you are like invited in a talk show, but it's not what I need for human-robot interaction. Okay, I do not need a talk show. I need things to be done, and so still it could be interesting to have the talk show with me integrated in the robot, but we have to pay attention to work on this and to grab what can be used. I say with subtlety. I would say essentially.
Okay, so thank you. Well, I would like to reflect a little bit on, let's say, some of the aspects that have been mentioned, because possible, let's say, modeling framework, which is also well known in our community, is this, let's say, system 1, system 2 distinction done by Kahneman, okay, where, you know, typically, but of course, I mean, this is not always the case, but typically some of the things that are where we can, let's say, accept uncertainty, errors, and so on and so forth, and mainly are based on perceptual task, looks like they can be somehow demanded to these kind of new tools. So these tools could be a sort of components, one of the components of, let's say, a much more complex architecture. And I think we have also seen in the cognitive architectures literature some attempts of doing that. And then this kind of, let's say, preliminary output provided by the system should be could be somehow refined by more, let's say, the different kinds of tools, mainly coming from, I don't know, symbolic approaches or something like this. So is this the only, I don't know, modeling idea that we have? Because we have seen today something like what Bob was showing us, right? A new, let's say, idea of using LLMs for, let's say, formulating problem space specification. But I mean, from a modeling perspective, from an architectural perspective, so is this the only, let's say, idea that we had as a community in order to eventually, let's say, try to integrate these components is larger systems that are able to, let's say, also deal with the limitations of large language models? Yeah, Ken.
So we're actually looking at two different ways of doing it. So we think of wanting to use a language model as yet another component in our high precision companion language understanding system, right? And so what would that component do? Under program control, it would be called upon to do two kinds of services. One is information extraction. So one of my students used BERT to extract qualitative portions of qualitative models across two different domains. You had to train it per domain with BERT. But an alum of mine, working at a company that shall remain nameless, has demonstrated that you could do that much more robustly now with today's language models. So information extraction of particular kinds, when you know the kind of information you want to extract, system tries to read something, can recognize it's that kind of thing, but the sentence is a little complicated, throw the language model at it to get that particular kind of information. That's way number one. Way number two is our system does really well with simple syntax. So if you get something that it's finding too complex, the chart's blowing up, go to the language model with the prompt that says, simplify this sentence, using routine 6, using this sort of set of conventions, and then have it simplify it, and then have the high precision system do the translation. So that's trying to use language models for what they're really good at, as a component under control of the rest of the cognitive architecture, as opposed to making them the central part of the cognitive architecture, which is what most of the company people want to do.
Yeah, Rachid, please.
I had a comment linked to this. In fact, I think it's true that it could be interesting to see because things are evolving, of course, and because even these LLMs today, there is uncertainty is not defined somehow. It's not so when the machine tells you something that you don't have any idea about the uncertainty. All things is our interpretation, and so the use of this kind of systems today is based essentially on the intelligent, I would say, interactor with the system. All of this is done this way, and so it gives challenges to robotics. I would say to cognitive architectures. Okay, using intelligently these kind of tools. One of them is the example of using them to formalize problems, to decompose problems, to etc. So I think it raises interesting questions, and perhaps we have to relook to this, because system 1, system 2, for the old timers before that, we knew that we had the different levels, hierarchical levels of decisions in any intelligent system which act physically in the environment. And there were a lot of debates about this, from subsumption to high level architecture, etc. And perhaps it's a moment to revise this again, to look if these tools, which are different from the tools that we had before, could be integrated, but not simply as we should not simply find the place in the architecture where to put them. I think we have to perhaps to reorganize, think differently about this architecture that we have today. There are several to integrate such systems, and also perhaps to influence their development in the future for different, I would say, topics.
Yeah, this relates to what Antonio was telling before. So we need also, let's say, a new theoretical conceptual jump to figure out a little bit how to, let's say, make use of this new system as tools, let's say, from an engineering perspective.
It's not things that we can plug somewhere.
Yeah.
I agree with you. It constrains us to revise what we know about cognition. So it constrains us even to revise our cognitive architecture and what we know about cognition. So because we are in front of a different form of cognition, of course, on artificial cognition, we have to revise it constrains us to revise our knowledge of what we mean about cognition. So it's not so simple as to put the large language model filling some box in a cognitive architecture. We have to revise the full ideas of cognitive architecture.
I guess I'm not sure about that. So I don't know that this tells us much about cognition at all. So so one thing it does tell us is some negative evidence. So if I have nothing but text, and I'm exposed to text for the equivalent of, in human terms, 10,000 years or more, depending on who you talk to, you still don't actually learn models of the world. You still don't learn how to reason or plan. You can do really good at predicting the next word in a lot of circumstances, right? But that's telling you something that some hypotheses that language is enough to ground yourself in the world, not true. Just not true. So it's giving us something about cognition when you interrogate these things, but they're often not positive messages. And so it's not clear to me that reorganizing our cognitive architectures around a model that does so subhuman in terms of amount of data required is a good idea. I think things like the cobweb work and other sorts of efforts to do more human-like learning might actually be more promising.
Okay, so another point that I would like to touch with you is that, in general, I would say in the AI community, there is this idea of, okay, we are starting to be aware, we were already aware as a community of the limitations, let's say, of these systems. But let's say one of the arguments that is, let's say, on the table now is that, yeah, we have this problem because we are dealing with the word models, while we need world models, so models of the world, of the environment. Okay, so if we have actually more data, multimodal data, so most of the problems that currently we have with these systems can be in principle can be solved. Okay, so I was just wondering whether and what extent you have some comments about this issue, because let's say one problem that comes out here is, again, the one of the integration of these multiple sources of, let's say, information upon which to build these word models. Another point concerns the fact that word models, for example, in biological cognitive system, are somehow built, I would say, yeah, online. Okay, there's this sort of online learning, while the main system that work today in the deep learning community are mainly based on supervised learning. So I want to know a little bit what you think about this. Couple of points here.
No, I think that we in as far as I can see, in the AI community, many people are trying to overcome the limitation of the structure of the large language models, because essentially it's a big feed-forward network, and very simplifying. So I see that there are many trials to consider, for example, large language model based on a recurrent network, or a model based on ways of learning. So maybe the auto prompting system, for example, which is the capability. So, in my opinion, I don't expect. We have to consider the fact that it is more or less 1 year that there is no big improvement in large language model. Yes, from ChatGPT 3.5 to 4, but there is no ChatGPT 5.0. Maybe there are some structure in the large language model that it is necessary to revise. So this is my impression. So I don't expect that augmenting the number of parameters we reach some new level of this kind of the operation of large language model. Maybe we need to consider different new large language model based on different kind of architectures.
So there's two things I just wanted to bring up. You had a great point about better world models. So one of the interesting approaches that Jitendra Malik is doing at Berkeley is he's basically saying, well, all this vision language thing isn't enough. You need action as well. And so somehow he's been doing robotic interaction as part of building up the model of the world. And so that's a much richer grounding than the visual language things I've been seeing. I don't know how well that's working out. As far as I can tell, this is very new work, and I haven't seen papers on it yet. The second thing on online learning, I think the way that today's artificial neural networks work are very unlike brains. I mean, we now know there's thousands of types of neurons in our brains, right? So these things are very cartoonish models of what's going on in our heads. So we're actually better off looking for better, more human-like language learning models that can be used for language and everything else. So obviously my group thinks analogy is the railroad to that. We have not tried to do an analogy-based language model. Maybe we should, but I would only be convinced to do that if it's something that's going to actually help us, in more interesting ways in the companion architecture. But I do think that the learning show in machine learning is far from over. And the fact that everyone's heavily investing in one thing right now, well, it's going to be interesting, right? There's a bubble, right? And now we're starting to see venture capitalists turning down the funding knob, and the bubble's starting to deflate, and people are starting to not get hired, okay? And so it's not going to have a crash because there's been too many things that are actually like making people money, okay? Speech recognition works now, right? I mean, that's just a huge thing. And all sorts of vision algorithms are used in all sorts of stuff now. So it won't be that there's an AI is done, but there may be a chatbots are done. And so that happens, windows open. And so if this community actually gets its act together and has some things to say about where to go next, we might actually help shape that conversation.
I think it should be good if other people contribute to the discussion. Yeah, I think again I agree on all of this, and also I think I know perhaps not only about this, but the more I see, the more I use, not using that much, but still, I'm impressed, really impressed, more and more impressed for a number of things, and I'm using a number of tools today. Speech, for example, translation. It's incredibly good today, and we use it and we are happy with it. Of course, we are the users. We humans, intelligence humans, are the users. So I'm really impressed and I'm using it, but I'm not satisfied. I'm not satisfied. I'm not happy with this because I found that we have not understood the mechanisms. And I feel, and I think as a roboticist, I'm obliged to do it also. Because you said this, but perhaps when we have more information about the world, when we have also images and videos, etc., we'll work. Well, we humans, I think if we have not done only this to live. We are using abstraction. We have built theories. We have built religions. We have built, we have institutions for living. Okay, so we had to use this, and this ability of doing this for me is key because it opens, etc., and goes beyond simply reproducing things and do not, and for me it's a key aspect. And I think modestly in robotics we are obliged to look at this because we have to close the loop completely and to be intelligent. To have the robot to show the intelligence. So I think for me, really, robotics in its full understanding is a real challenge for and still today is a real challenge for AI, essentially, for cognitive systems, for cognitive architecture, etc. Until today. Thank you. And if you put the human there, then really it's absolutely necessary.
Yeah. So I will follow your suggestion. So do you have other, let's say, comments from the audience? I think we can open up a little bit the discussion about this issue. I think it's important that we as a community, let's say, start to explicitly thinking about what is happening now at the technological level. How can we help to shape, as Ken was suggesting, also the development of these new kind of tools in the direction that we prefer. So, yeah.
So one of the things I just wanted to mention, if people are not aware of it, there's a great paper by Josh Tenenbaum and Nancy Kanwasher. The first author is Mawald, came out a couple years ago, but where they really looked at like neuroscientific data and what language models do and did a in-depth comparison to try to kind of understand what parts of human cognition, sort of map onto language models. Michael Woolridge has a more recent paper that kind of is a little bit in response to that says, oh, well, there's all these psychological effects, priming effects, things like you would sort of expect from language models that are more consistent with human cognition. But those are both kind of good papers for understanding where we think language models are with respect to, the actual properties of human cognition. One of the things that I wanted to mention that I've been thinking about is that mostly I think about language models as a tool, right? They're like this new thing in my tool belt that I can use to do the things that I care about, right? That's really the way that I think about them. But there are these people that are out there reinventing cognitive architectures. Some of you might know Koala. It's come out of Tom Griffith's lab. And they're essentially saying like, well, we need an episodic memory and we need a semantic memory. And so, I don't know, Ken, what your comment was about getting our act together, but like, I feel like there's these design patterns. I'm not talking about the common model of cognition, although that might be part of it, but there's these design patterns that we kind of have been building and thinking about and refining as a community over, I've been involved for 30 years now, but, it goes back a long ways. And I feel like that there's some opportunity to try to communicate what those design patterns are independent of a particular architecture and things like that, so that essentially if there is somebody that's going to create the language model cognitive architecture, that at least we're providing kind of a roadmap or a set of principles for that. And I'll just mention one of these principles that I think of a lot is the notion that when you do knowledge, when you do knowledge search, when you're pulling stuff from your memory, unless you're in a kind of very reactive mode, you don't commit to that. There's then this step back from that where you reflect and you say, okay, I'm going to go from knowledge search to problem search, and I'm going to think about whether the things that I just retrieved are really the right things to do, right? And language models don't do anything that comparable to problem search. The people that are doing agentic stuff are starting to think about that. And so that's just one example of a design pattern. I think there's a bunch of those that we as a community could potentially put forward and communicate at that level, which I think it would give us a little bit more visibility about what it is. It's hard work, and I don't know exactly how to do it, but that's what I've been thinking about.
Well, part of it is there's an extreme bias that anything that's not neural is irrelevant. So there were at least 3 faculty candidates who actually, when you bring up the idea of cognitive architecture, they'd never heard of it. I sent them off to read the SOAR book, in fact, because in fact they just don't hear about it. They just don't know about it. And so whatever we're saying in whatever venues we're saying it in, it's not communicating. It's just not getting across.
I don't want to continue to talk, but I will say that, you know, part of what I think I'm trying to advocate for is, can we as a community think more about what is our message and can we get it across, rather than, because I think that, you know, this is an old branded thing, right? That, you know, through the SOAR guy, the ACTAR guy, the companions guy, that, like, I think there's more common principles, but we'd have to think about them and articulate them. And where is it?
Yeah, I'm gonna strongly second that. I was thinking along the same lines, and then you spoke, took a lot of not all the wind out of my sails, but like, I think you brought up a very good point. And you know, you're talking about, oh, we have talked about this. I mean, we literally have, right? Like ACS has been around for a while, and cognitive architectures have been around for a long time. But I think, I mean, I'm gonna maybe take even a stronger stance. I think that we basically have to produce something that is maybe not entirely neural, but like very largely neural, multimodal, and then we have to present it somewhere very big, right? Like that's someone was asking about how do we communicate these things. The answer is, we go to AAAI, we get a big talk, and we say, like, here's an agent. It's like literally it's walking around the world doing things, because I get these sense from, you know, obviously I'm still in PhD, and there's a lot of focus on neural stuff in some of the offices that I go to and hang out with my friends, and like they're stuck on, well, if it's agentic, it's got to have some kind of loop maybe, and like maybe memories or something, but I'm not sure how to do that. I went to a venture capital conference, and there's something called like the Lang chain, right? If some of you have heard of it, it's a GitHub repo that someone made to like make a library for chain of thought reasoning easier. And I was looking through the repo. He was, you know, introducing it on stage and everything. Someone had just given him like $10 billion to do a startup. And it's like, oh, well, you know, here's like a little memory thing that you can plug in, and like maybe it'll hold some memories for your cognitive architecture. And like, here's how you can have the thing, remember episodes that I was talking about before. And I was like, you're just reinventing a cognitive architecture. And you're right, like no one had heard anything about those. So I think the answer is to stop seeing, as you say, large language models as a tool. And I think in general to stop seeing these huge neural networks as just large language models. I mean, I was thinking about, I use a lot of large vision models. There are huge video models. There are models of motor control. And all of these things are beginning to be trained on these huge data sets. And I think part of the answer is, how do we work within this realm, rather than saying like, all right, we're going to use a large language model. It's going to take in text. It's going to give us text in some nice format, and we're just using it as a translator. We should be working on, how do we use the embeddings? How do we use the embedding space, the feature space, and how do we take those and turn them into something cognitive instead of just something statistical? How do we make it look at its own embedding space and use that to do semantic parsing, and to use that to do semantic memories and episodic memories, and multimodal things, where we're not talking about things like, oh, it's a magic black box and it comes in and then we get something nice for our system. We're talking about like, it's really a part of our system. And it's literally transforming huge raw data into something nice and small and abstract, because that's a large part what they do is they abstract inputs. So I guess, I don't know, this is my rant on the subject is we need to start looking at large language models and large vision models as like genuine parts of cognition that do some kind of interesting abstraction, and then figure out how to use that abstraction in the way that we've been talking about using abstractions and qualitative representations for years.
Well, just to, even though I mostly disagree, here's a piece of evidence for your perspective. If you look at the semantic web research in Europe, so stock semantic web, how to make RDF and OWL and all that stuff scale and all that, that's now taken over by industry. Industry owns that. Okay, it is a super successful example of commercialization of hardcore knowledge representation in everyday industrial life. So what they're doing as one of the big research vectors is, how do we now actually complement that with embedding models to, for instance, help guide reasoning? Okay, and so they're finding that there's ways in which that can actually be very useful. So that sort of hybrid strategy is actually a very good strategy.
Yes, no, I agree with you, Ken. However, we need to think more in deep about what does it mean, this kind of integration. So because there is an engineering integration which I use the API of ChatGPT or whatever, and then I integrate in my system. And in my opinion, maybe we need some sort of deep reflection. What does it mean to have an hybrid system? What is the meaning of the? So I would like to see some studies on more theoretical discussion on what does it mean integrating a large language model in a in parts or even a whole cognitive architecture.
Yeah, and also what about, if I may add, let's say the final comment, what about also, let's say, the focus on, let's say, problems where we have few data? Because I think this is another, let's say, aspect, right? So as you were mentioning, let's say in cognitive science, we are also interested, let's say, in some cases, I would say, to the plausibility of the models that, let's say, we also use as to build computational artifacts, right? So this could be another strategy to actually test our model. So see what can, for example, what we can do with these kind of models that where we have few data that, for example, we cannot do by using standard state-of-the-art technology. So this would be another, I would say, I don't know, evaluation strategy that we could use as a community to show that there are some gaps here and there that can be that we are able to deal with compared to state-of-the-art technology that use these things. I don't know what you think about that. Yeah, I mean, they are. I mean, in many cases, they are state-of-the-art on the benchmark that they, let's say, use. So, no.
And so we're working on understanding language, for example, and at that time, today, we thought it was necessary to understand a sentence to translate it. Today we know it's not necessary. Okay, but there are situations where we need to understand this. We still need grammar, need to find the verb, need to find etc. For not for translation, for something else. And even though it's for translation, 99%, not 100%, of course, success. So I think one of the criteria could be this: what do we want to do exactly with this cognition? So, and there are I think transformations or functions that could be done without I would say, this deep understanding of the world, or of the sentence, or the thing, that can be done directly or through statistically. Others no. And I think in robotics it happens very quickly, because because the environment can change. The challenge of robotics is that it's not only to do a task, but to do it in any context. Immediately you have this difficulty, and we very quickly, we know very well how much limited our systems today. I spend my life saying our robots do not work. For me, the robots do not work. Okay, we know this very well. They work in specific situations where you put a number of guards around this. Okay, and there is a one there behind. If not, we have big issues. And I think it's one of the key aspects to find and be modestly put some, I would say, landmarks of things where there is a need to do abstraction, to formulate, to reuse information smartly, avoid intelligently, etc.
Okay, other thoughts from the audience? Okay, yeah, please.
Hello. So I'm sorry if once again I keep apologizing about potential stupidity of my questions. My first conference. I'm a psychologist. I'm looking at the situation kind of from the outside, but also from the inside. Even though I'm also a computational psychologist, so I work on cognitive architectures, and I'm comparing to very simple neural networks, not transformers. But as I understand the history or how we arrived at this moment, is that one of the watershed moments that happened in the past, just over the past 10 years, was the VisionNet competition or VisionNet challenge. And it feels like at the moment, both the AI community and the psychology community is lacking this kind of benchmark toward which they could strive. Yeah, I feel. Yeah. Yeah, I'll stop. Yeah.
You used the B word, yeah. So, look, this whole thing about state of the art, this nonsense about state of the art, is all because of so-called benchmarks, which are a terrible idea. They've always been a terrible idea. Doing experimental evaluation is a fine idea. Trying to do systematic studies to understand weaknesses and sources of power, that's great. Benchmarks, crazy idea. It leads to competitions and mindless bake-offs, and the claim that this particular system or this particular approach is vastly outstripped others, when the other approaches, for example, some that we like, are very well suited for other things that have, for example, when you hear about state of the art, you never hear anyone talk about the rate of learning, because the benchmarks have a fixed size. And that's crazy, because you want a system that is anything like a human, rate of learning is important. If you want to deal with settings where there is not very much data, rate of learning is important. So that's one of the reasons why I think that the term state of the art is terrible. It's one of the reasons why benchmarks are terrible. So you really think you want more of that? This is how the AI planning community went down its path. They still have symbolic methods, but they are just as obsessed with state of the art. It's why almost everyone in the planning community uses variations on the fast forward algorithm rather than exploring the entire space of methods, which would be much healthier from a research perspective. So I hope you don't really mean that, do you?
Well, yeah, so I take that on board. Yeah. As usual, there is no sort of 100% working solution. You always have to mitigate. Yeah, there are exceptions. There are rules of thumb. But I still I hold on to my opinion that ImageNet was an important, at least I hold on to my perception of history that ImageNet formed an important part of. But the other thing about ImageNet is that at the time when it was proposed, it was perceived to be an impossible task. I think it was a consensus that
Sorry,
there were way too many.
ImageNet was impossible? No, no, ImageNet, no, you misunderstand the history. So the improvement that Hinton made in 2011 in ImageNet was a change in 25% of error rate. It wasn't a huge leap, but things had been going down at a couple of percent a year. So 25% reduction in error rate was huge by contrast with that. And that's why everyone jumped on.
Yeah.
Okay, but it wasn't, and by the way, that was 25% error rate at n, where n was much bigger than 1. So it means of the top 10, I think it was 10, you'd have a 25%, you'd have an X% chance at being in the right answer in there. So, and it took several years after that of people tuning and refining systems to get down to even accuracy at 1.
I do believe that we should be defining problems, challenge problems to drive the research community. Okay, and push things in directions that we want. And we should find problems that we think some of the popular techniques will not do well at, and some of the other techniques might do better at. That's not the same as finding benchmarks, but yeah.
Yeah.
Wanted to get back to the original question that we were wanting to talk about, how LLMs might be used, whether as tools or in the cognitive systems context. And one thing, if you were a new PhD student or a young researcher and had ideas about a new cognitive architecture or the new interaction between certain modules in the cognitive architecture, that's a big job to try to write it from scratch. Something like SOAR took 30, 40 years to get to where it is right now. But if you were able to outline what the various modules you believed were important, you could fill in other modules like perhaps the language module or the planning execution module. There is some interesting work, despite some of the negative results that we've heard from Compapati and others in using LLMs for action planning and execution, or to use it for vision or other modules and fill in those quickly with something down and dirty like an LLM and work on the other important parts and then come back to those and do something better. It could get you up and going with some interesting research examinations on cognitive architectures, complicated integrated systems without having to spend an inordinate amount of time to fill in some of those other module boxes. That's one possibility. I think it could be very valuable.
I want to jump back to the rather heated. I mean, I think I'm probably going to put Rachid. Yeah, I think he'll be a fan of this, but I think I'll avoid the B word for you. But let's say challenged problems that are going to be appealing to this particular group, and that I think are like the way to show what I was talking about earlier, where it's like, look, we have a system that does a whole thing, or the more robotics oriented one. I mean, I'm thinking about Alfred. There's like a number of systems where it's like you have a butler robot kind of situation, and it's got to do a whole variety of things. I mean, I know we work with it with SOAR, where it's like you have to, plan out how you're going to solve the task, but also navigate in the real world and also do some motor control and also do some reasoning and natural language processing. And I mean, they are considered benchmarks. There are scores that you can get. I think that they're not super highly scored on yet. I think that the score doesn't really matter. I don't think it reflects anything super interesting. But I think that if we can demonstrate that we can do those tasks and also extend those benchmarks, those challenge problems, where it's like, look, we can operate a system in a very complex world in a multimodal way. Those are the kind of challenges and benchmarks that I think that we need to be approaching as a group or like Well, I mean, I think we should. I think that maybe not internally, but I think that if we want to get traction with the broader AI community at the moment, benchmarks are the way to go. That's what people want
Well,
to see. You
so-
can get papers published in tons of AI journals right now just by beating benchmarks, which is
So-
it's
so-
ridiculous. But you have to get published to get hurt.
So we actually put out the coloring book object data set to throw the gauntlet down on data efficient learning. And to date, not one deep learning person has touched it,
Yeah.
to our knowledge, right? I mean, they just view this as crazy, right? I mean, the ones we've talked to basically just said, "Bah, why would we do this?" And so there is a problem. What you need to do is have challenge problems that speak to broader communities outside the technical community, where they say, oh, holy crap, I can actually have the system adapt to me continually as opposed to sending it back to the factory for being retrained. Everybody wants adaptability. So everybody wants incremental learning. And that's something that we actually have a handle on. And if we can find ways to get that across to people in practical ways, we'll do very well.
Okay, so well, thank you really to all of you for this interesting discussion about this important issue. So thank you, Antonio, Ken, and Rachid. And okay, we are closing this this conference. Really, I would like to say thank you to, let's say, the ACS Foundation. It was an honor for us to organize this conference, and also like to thank the main organizers, which are actually Agnese and Arianna, which are over there, and thank you very much. We left, let's say, some time for having a sort of, let's say, community meeting. So, Mike, I mean, you mentioned it. So you or Pat, I mean, you can come here and we can discuss a little bit, I mean, what's going to happen next. So, okay. So.